Okay, just getting things adjusted here. So we're going to continue on with talking about our quadrilaterals unit, and today we're going to talk about special parallelograms. So these are specific varieties of parallelograms. Um, we've already talked about the names of them. It's a rhombus, a rectangle, and a square. So on Tuesday, when we talked about classifying, we did that diagram tree, and on the right-hand side was where the parallelogram family lives. So we have parallelograms, and then we have rhombi, rectangles, and squares on that right side. So now we're going to focus on those today. Okay, and there's a lot involved here, so I'm going to go ahead and get started. So just to remind us, a rhombus is a parallelogram with 4 congruent sides. Okay, and then we say rhombi have all the properties of a parallelogram. So all the properties that we talked about with a parallelogram, a rhombus has it, but they have 2 additional properties, which are these following theorems. So first theorem is that the diagonals are perpendicular. All right. And if I want to mark my picture up to show that, you could put all those boxes all the way around here, but I'm just doing 2 of them, just so it's not cluttered. But that means every angle right here at this intersection of your diagonals, every angle here is 90 degrees. That is an important fact to remember. And we could write this as AC is perpendicular to BD. This upside down T looking thing is the symbol for perpendicular, in case you didn't know. Okay? So the second theorem is that a diagonal bisects a pair of opposite angles. So remember what it means to bisect. Bisect means you cut something in half. So what that says is this diagonal, like this specific one right here, is going to cut angle A and angle C in half. And so to mark that, we would put one little arc there for each of those pieces, and then one little arc here for each of these pieces. Okay, so that's that. Next is a rectangle, which remember has 4 right angles. And then we say rectangles have all the properties of a parallelogram and one extra thing. So we say that the diagonals are congruent. And so to mark that, we could, if AC is the whole thing, when they meet in the middle, it's going to, and because it's still a parallelogram, it's going to cut it in half. But then, because the diagonals are congruent, every piece of the diagonal is the same length. So we put 1 tick mark everywhere instead of 2 right here. Okay, and I forgot to add up here on rhombus. You only need 1 diagonal to bisect a pair of opposite angles, so I just drew 1. But you can have the other one. You can have the other pair of opposite angles being bisected. Okay, you can have both, but you only need 1. And then lastly, a square. Remember, a square is a parallelogram with 4 congruent sides and 4 right angles. Okay, it's both a rhombus and a rectangle. So a square has all a parallelogram's properties and all the properties of a rhombus and a rectangle. Okay, square has every property we've talked about as far as parallelograms, rhombi, and squares. All right, let's use some of these theorems in practice. Okay, so I told you it's a rhombus. We want the indicated measures. They tell us that BC is 28, so I'm going to mark that where it's at. And BD, that's the diagonal. So let me write that what that is. Okay, what is CD? CD is right here. Because it's a rhombus, we know that all 4 sides of a rhombus have the same length, so this one's also going to be 28. Then we want FD. FD is a piece of this diagonal, and we know that this diagonal is going to be cut in half, so if the whole thing is 32, FD is supposed to be 16. All right. Now this next one, there's a lot involved. There's 8 angle measures you need to find. But once you find a couple, it kind of goes pretty quickly. So let's start where we know something easily. So I'm going to start right here actually at angle 8. That's where I would start. Our first theorem said that the diagonals of a rhombus are perpendicular, which means every angle at this intersection point of your diagonals is supposed to be 90 degrees. So angle 8 is at that intersection, so we know it is going to be 90 degrees. Okay? I'm going to write that right there so I know it. Okay? Now I'm going to use the property that a diagonal of a rhombus bisects the opposite angles. So in this area right here, if this half of the angle is 38 degrees, then this other half marked angle 3 also needs to be 38 degrees. So we're going to say that angle 3 is 38 degrees. Okay. Now, because it's a rhombus, we also know it's a parallelogram, and we know that opposite angles in a rhombus and a parallelogram are congruent. So if both of these pieces right here are 38 degrees, that means both of these up here are 38 degrees. So we're going to go ahead and mark those. Let me mark here what we've got. So we've got 38 there, 38 there, and 38 there. Okay. Now you have some options to figure out some of these other ones, but what I did was I started right here with angle 6, because if I get angle 6, I can get the rest of these. And I noticed that I have me a small triangle right here. And I remember from geometry A that all 3 angles in a triangle have to add up to 180 degrees. And I know what 2 of them are, so I can find the third one easily. So for angle 6, I'm going to do the 180, subtract 90, subtract 38. When you do that, you get 52 degrees. This is 52 degrees. Now I'm going to go back to the property of rhombus. If this piece of the angle is 52, so is this piece. So angle 7 is 52 degrees also. And then if these are 52, then because it's a rhombus and a parallelogram, these other two pieces that are across from it also have to be 52. Okay, now I'm going to adjust my camera a little bit, see if I can get it to work. Okay, I know that angle's kind of weird, but I hope you can see it. All right, now we have a rectangle and we want all these angle measures. So this time I've got them marked, labeled by their letter names. We have to follow these letters. So MJK, what is that angle? MJK. That is this whole piece right here. So it's this one and it's that one that's labeled 27. We know it's a rectangle, so we know that that is supposed to be 90 degrees. That is a really bad 90, so I'm going to fix it. And in fact, since it's a rectangle, all of these are 90 degrees. Okay? Now we want the measure of MJL, so I'm going to follow those letters. MJL. So let me clean this up a little bit. Let me just put our box in. So MJL. So we already know that part of it is 27 degrees. The whole thing is supposed to be 90 degrees. So this harkens back to the complementary angles that we talked about way at the beginning of Geometry A. Two angles that add up to 90 degrees are complementary. So we're going to do 90, subtract the 27, and that will give us 63 degrees. So this is 63 degrees. All right, let's keep going. JLK. JLK. That's this bottom piece right here. Okay. To find that piece, we're going to use the property of a parallelogram again, that the opposite angles are congruent. So if both these pieces over here are 63 and 27, oh, I said that wrong. I apologize. I said that wrong. A rectangle is always a parallelogram. So what we have to do this time is we have to use the fact that we have alternate interior angles here. And I misspoke. So if you have 27 as the smaller piece and 63 is the bigger piece, when you come down across here, we're going to trade places. So this one's going to be 27 and this one's going to be 63. That would make JLK. That would be this upper piece right here, not the lower one right there. It's the upper one, JLK. So that means that one is also 63 degrees. All right. Now we want KML. KML, that's this small piece right here. And again, using alternate interior angles, we know that's going to be 27 again, and that's 63. And this one's 27, and that's 63. So this one's going to be 27 degrees. Now we want the measure of angle MNL. So MNL is this angle right here. How am I going to find that? Well, I'm noticing right here that we have a triangle. We know two of the angles are 27 degrees, so we can find the third one. Using 180 minus 27 minus 27. You figured that out, you're going to get 126 degrees. All right. Next one. It's a rectangle again. This time we know that RT is 5x minus 14 and US is 2x plus 10. Looking at our picture, RT is a diagonal, US is a diagonal. We know the theorem says diagonals are congruent, so congruent means they're equal. So I'm going to set those expressions equal to each other. Subtract 2x. Times 3. X is going to be 8. Now to find these actual lengths, we're going to go plug 8 in. So 5 times 8 minus 14. That should give you 26. 2 times 8 plus 10. That's also going to give you 26. Okay, we know we did it right because our diagonals of this had the same length. Okay, now we're going to say our theorems backwards, so we're going to use the converses of them. So we're going to go ahead and mark this. So these should already have the 90s in there. I forgot to add them for you. So all we know is that this is a parallelogram, and it just so happens that the diagonals are perpendicular. So we're going to say that if the diagonals of a, now I'm putting p-gram, but just know that that means parallelogram. Oops, no comma. Are perpendicular, then we say that the p-gram, parallelogram, is a rhombus. Okay? So let's mark this one up. I forgot to mark it. So we're going to put one arc here, one arc right there. So what do we have here? We have a pair of opposite angles is bisected by the diagonal. How do I know they're bisected? Because each piece has one little congruent arc mark, so that means they're all the same length. So we say if the, let's say if A, not the, if a diagonal of a p-gram bisects a pair of opposite angles, then the p-gram is a rhombus. Okay? I need to mark this one up to match what I want to say because I forgot to add it for you all, and then I apologize for that. So what have I marked? I have marked that every small piece of each diagonal is the same length. That means that they are congruent. So what are we going to say? We're going to say if the diagonals of a p-gram are congruent, then the p-gram is a rectangle. So those are the converses of the theorems. Now we're going to use these to say if we have a congruent, if we have a rhombus or rectangle. So now on your homework, these will already be marked for you. I forgot to do that, so we'll have to add them ourselves. But anyway, so we're going to add this. We're going to put 2 this time. So that's all we're given. Is this parallelogram a rhombus or a rectangle, and justify your answer? So let's step back and think. What were we given? Or what did we add that Mr. T forgot to give you? It's more like what it is. But we're given a pair of opposite angles that are bisected by the diagonal. How do we know they're bisected? Because everybody has the same number of little arc marks. And so we're going to say this is a rhombus. Why is it a rhombus? Because a diagonal, I'm abbreviating, a diagonal bisects a pair of opposite sides. Not sides, angles. Okay? Let's see the next one. So it should have been pre-marked, but again, it's not. I forgot. So we're going to add this into here. So is that parallelogram a rhombus or a rectangle? So what are we given? Well, I noticed that these pieces of the diagonal AC are the same length. The pieces of the diagonal of BD are the same length, but everybody's not the same length. Which tells me, and it should tell you, that these diagonals are not congruent, which is a property of the rectangle. Even though the shape looks like a rectangle, I know this looks rectangular, but because of the way I've got this marked, it's not a rectangle anymore. So it is simply a parallelogram. So is it a rhombus or a rectangle? It's neither. Why? Because the diagonals simply bisect each other. And they are not congruent. That's why. Okay, that's all we have on special parallelograms. So remember your properties of a rhombus and a rectangle. And make sure you watch this video before you do your homework. And if you have any questions, let me know.